Hello everyone, welcome to Mind is Fun Education. So far we were talking about the joint probabilities. In this video we will take several examples. So let's first of all talk about this first example, and as we go on the example would be on the tougher side. First of all, let's look at this example. Consider an experiment in which a four-sided die, so let's imagine that you have the four-sided die, and which have label 0, 1, 2 and 3 is thrown once to determine how many times a fair coin is to be flipped. In the sample space of this experiment, the random variable n and k are defined by, so random variable n is defined by the result of the die roll, and k is the total number of hits resulting from the coin flip. First of all, you will have to understand what this experiment is saying. So what you are doing, you have a tetrahedral die. So from the start of the lecture we have taken this tetrahedral die. So it has the four side, and the four side is marked with this label 0, 1, 2 and 3. So what you are doing, you are throwing it once and maybe you will get 2, right? In the next step what you will do, you will flip a fair coin 2 times, or maybe once you have thrown the dice, or maybe you will get 3. So in that case, next step what you will do, you will flip the coin 3 times, or maybe on the die you have got the 0, so in that case you will not flip the coin. Now coming to this random variable, so for this particular example or the experiment we have defined 2 random variables. For an experiment we can have multiple random variables, so we have defined these 2 random variables. Let's first of all understand this, what are these and how these random variables has been defined. So this random variable n is the result of the die roll. So if I ask you what this random variable n can take the values, so this random variable, let's say, is taking the value little n. So little n will belong to from this set, right? And what are these values? These values are nothing but the possible output that we can get on the thrown of the dice. So this is how it has been defined, right? So n is the total result, so the result of the die roll. So maybe n can take the value 0, or maybe 1, or maybe 2, or maybe 3. So that is why combinedly I have written that n takes the value little n, and this little n belongs to this set. Coming to the another random variable, how we have defined, so k is the total number of hits resulting from the coin flip. So how many times you will flip the coin, that depends on what you have got on the die. So maybe you will flip the coin 0 times, or maybe once, or maybe twice, or maybe thrice, depending upon how many times you are flipping the coin, you will get the head. So this, let's say this random variable k takes the value little k, and this little k will belongs to the set where it takes the value 0, 1, 2 and 3. So maybe on the die roll you will get the value 0, so in that case you will not flip the coin, so total number of hits you will get 0. So this random variable k takes the value 0. Or maybe on thrown of the dice you have got the 1, in that case you will flip the coin once, in that case you may get the tail or maybe head. So in that case random variable take the value 0 or 1. If you are getting the tail, that means total number of heads are 0, that is why random variable k will take the value 0, or random variable k will take the value 1 depending upon what you have got on the flipping of coin. So random variable can take the. Similarly, if you got the 3 on the die roll, so you will toss the coin 3 times, so you can get the 0 head. Maybe you will have all the tails, or 1 head, 2 tails, or maybe all of the 3 odd heads. So maximum value that random variable this k takes is 3, or minimum is 0, or maybe it can take 1 or 2 also. So you got the idea that how these random variables are taking the values. Coming to the part A, determine this probability. First of all, you have to recognize what is this notation. So this small p, that means we are talking about the probability mass function in case of the discrete random variable, and this subscript that is written here in capital N. So we are talking about this random variable capital N, because for an experiment we can have multiple random variables. So that is why we are here in the subscript we are writing N, so that we can get to know which random variable we are talking about, and it is the function of this little value n, because this random variable n can takes the value this little n depending upon how we have defined the set. So it will be the function of this value little n. So in part A we are just talking about this, that means we are talking about just throwing a die. So the total number of outcomes are, the total number of elements in the sample space are 4. The coin is, sorry, the die is fair, so all will have the equally probable. So we can directly say that, or we can even draw this PMF. So let's draw it. So let's say on the y-axis we are talking about the probabilities. So on the y-axis we have the probability of random variable n taking the values little n, and on the x-axis the random variable can takes the value little n, and these little n are the possible values that are 0 and 1 and 2 and 3. All will be equally probable. That means random variable n can takes the value 0 with the probability 1 divided by 4, n can take the value 1 with the probability 1 divided by 4, capital N can take the value 2 with the probability 1 divided by 4, and capital N can take the value 3, that is with the probability 1 divided by 4. So this is the PMF of this random variable n. Right, now coming to this part B, we have to determine the joint probability. Again, coming to the notation, we are talking about the probabilities PMF of these two random variable n, k simultaneously, right? So overall this is nothing but the joint probabilities. We are talking about the happening of these two events, that is random variable little n takes the value, sorry, random variable n takes the value little n, and random variable k takes the value little k simultaneously. So we are talking about this joint probabilities. Before proceeding calculating these probabilities, first of all you need to have info that how these two random variables are related. If you observe, these two random variables are dependent. How? Let's say if you know the value that on throwing the dice you have got the 0. So in that case random variable n will take the value 0, right? And once you have got this info, you can tell a lot about the random variable k. How? If throwing a die is resulted to 0, that means you are 100% sure that the total number of heads are going to be 0 without, because if n is 0, that means you are not going to even flip the coin, right? So this random variable tells a lot about the random variable k. Or maybe random variable n will take the value 1, this might be also the case. In that case you can say that k will take the value either 0 or k will take the value 1. How? n is taking the value 1, that means you are saying that you will flip the coin once, and if you flip the coin once, maybe you will get the head or maybe you will get the tail. If you are getting the tail, that means you are not getting any heads, so total number of heads will be 0, so random variable k will take the value 0. If you are getting the head, that means k will take the value 1. So depending upon the values that this random variable is taking, you are saying a lot of things about the random variable k. So the ultimate point is that these random variables are dependent. So this is the case of dependency, and you will have to deal the joint probabilities accordingly. Now coming to this joint probabilities, we are talking about the joint event. So that means random variable x takes the value little n, and at the same time random variable n takes the value little n, and random variable k takes the value little k. So what are the possible pairs that we can talk about? So these are the possible values that n can take, these are the possible values that k can take. So we can, let's say, directly jump that what are the possible values that we can have it. So these are the values that random variable n can take, and let's say these are the possible values that random variable k can take. So let me write down here also, so that you got to know that which side is which one. And all the pairs are not possible pair. Let me show you how. So n can take the value 0, yes, and once n take the value 0, k will be 0. How? If we are saying that on throwing of the dice we have got the 0, that means we are not flipping the coin, that means the total number of heads will be 0, so k will take the value 0. There will be no point of talking about that n takes the value 0 and k takes the value 1. So these will be impossible events, right? So we will be just talking about this probability in this case, and these will be assigned to 0 probabilities, right? Once, let's say, this random variable n takes the value 1, so that means we will be flipping the coin once. So in that case k can take the value 0, and maybe k can take also the value 1, right? Because we are flipping the coin once, so there is a possibility that we will get the tail only, so no head, so k will take the value 0, and in that case maybe we will get one head, so k will take the value 1. These will be impossible. If we are flipping the coin once, there is no case that we will get the 2 number of heads, so these will be impossible, right? So overall point is that now we can talk about the joint probabilities, right? We are good to go with the joint probabilities, finding the probabilities of this joint event. So let's first of all find the very first case. So we are talking about the joint PMF of these random variable n and k, where n takes the value 0 and k takes the value 0. I hope you are very much comfortable with these notation. So this is the PMF notation in terms of the probabilities. This is how you can write. So we are talking about this probability of the event that random variable n takes the value 0, and at the same time k takes the value 0. So either you can write like this or in terms of the PMF notation. So I will be using PMF notation. So this event, and one point to note, we are talking about the joint probabilities, and these two random variables are dependent, so accordingly you will have to talk about, right? So first what we are doing throwing the die. So first we will talk about the probability of this random variable n taking the value 0. So this event has occurred. Once this event has occurred, that means this random variable n takes the value 0. Random variable n takes the value 0. What's the probability that k will take the value 0? So here we are talking about the conditional probability of random variable k under the event or under where random variable n takes the value little n. So this will be the conditional probability, right? I hope you are very much clear if you have seen my videos. These are the joint probabilities and these are not the independent random variable, these are dependent random variable. That is why here we have this conditional PMF, right? So probability that random variable n takes the value 0 will have 1 divided by 4, and once we know that random variable n takes the value 0, so we are not going to flip the coin. So k takes the value 0, that will be a very much certain event with the probability 1, right? Because once we know that k is 0, we are not going to even flip the coin. So there will be no asking, we are very much certain that the total number of heads will be 0, so that is why the probability is here 1. So we can now write here this event where random variable n takes the value 0 and k takes the value 0 with the probability 1 divided by 4. Let's proceed further, and this probability will be 0. I think we are good there, right? Because there is no question of asking that you are getting on the thrown of the dice, you have got the 0 and you will get 1 head, right? Because that will be impossible event. If you are getting 0, that means you are not going to flip the coin and there will be no question that you will get the 1 head. So that is why these are impossible event and these will have the probabilities 0. Let's talk about this event where random variable n takes the value 1 and k takes the value 0. So we are talking about the probabilities of joint probabilities where n takes the value 1 and k takes the value 0. So we are talking about this conditional PMF of this random variable k under the event that n has taken the value 1. What's the probability that k will take the value 0, right? So getting this n 1 or random variable n take the value 1, that will have the probability 1 divided by 4 times. So you are flipping a coin once, you will get 0 number of heads, that means you are getting the tail with the probability 1 divided by 2, right? So there it will be 1 divided by 8, so this probability will be 1 divided by 8. Similarly you can find this probability will be 1 divided by 8 and these will be 0. Let me do it for one case and I hope you will be able to do for all the cases. Let me do for this case where random variable takes the value 3, n takes the value 3 and k takes the value 2. Let me do it for this case, right? So we are talking about the probability of these joint where random variable n takes the value 3 and k takes the value 2. So this will be, so we are doing the first throwing the dice. So we will be talking about the probability that random variable n takes the value 3, and once this event has happened, so that means n has taken the value 3, what will be the probability that random variable k will take the value 2. So overall we are talking about this conditional PMF or the probability of this particular event. So again, upon throwing the dice, you will get the 3. It will have the probability 1 divided by 4 times. So how many times you are flipping the coin? You have got the 3 on the die. That means you are going to flip the coin 3 times. What's the probability that you will get 2 head? So under this event, what's the probability that you will get 2 head? So you are flipping the coin 3 times. What's the probability you will get 2 head? So flipping the coin 3 times, these are the possible outcomes, right? So you will get the 2 head. So what are those cases? Those cases are this one, right, this one, right, and this one. So there are 3 cases where you are getting the 2 heads exactly, right? So that will be 3 divided by all the possible outcome. So 8, right? So overall this probability will be 3 divided by 32. So we are talking about this probability, it will be 3 divided by 32. Let me now fill other probabilities. So this will be 1 divided by 32. So you can even directly answer these. So random variable takes the value 3, right? So that means you are going to flip the coin 3 times, and let's say k is taking the value 0. That means you are not getting any head. So out of those 8 possible outcome, right, there will be one possibility that you will get the 3 tails. So 1 divided by 4 times 1 divided by 8, that will be 1 divided by 32. Similarly, you can talk about this case where you are getting 1 head out of the, so this probability will be again 3 divided by 32, and again all of the heads when die roll has shown the 3, this will be 1 divided by 32. I think at this point you will be able to determine all this probability. Anyhow, I have already determined this, but you can do that, right? Similarly for this case also, where random variable takes the value 2 and k takes the values these. So this probability will be 1 divided by 16, and this will be 1 divided by 8, and this will be 1 divided by 16, and this will be impossible event to happen. We have answered this part to question. So this is 1 and this is B. Now come to this part 3, that is C, determine and sketch. So again you will have to see what PMF we are talking about. So we are talking about this PMF or the conditional PMF of this random variable k under this evidence or under this condition where this random variable n is taking the value 2. So what's the probability or what's the PMF of this one, right? So what you can do, your initial universe is this one, right? Now what you are doing some conditioning. You are saying that instead of looking the whole universe, now let's look at this universe where random variable n takes the value 2. So random variable n takes the value 2. So now I will be looking at this universe. Now I am in conditional universe, and we know that in conditional universe the conditional probabilities are also legitimate probabilities. So in this conditional universe I have to find the probabilities that random variable k takes the value 0 and 1 and 2 and 3. So for all these cases, right, because this will be the function of k once we have fixed the value of n. Let's try to determine this conditional PMF. So what we want to do, we want to find the probability. So let me directly sketch it. So let's say on the y-axis we have the conditional probability of this random variable k under given that random variable n takes the value 2, and on the x-axis k can take the value 0, 1, 2 and 3. Right, so let's suppose first of all that random variable, we want to find the probability that random variable takes the k takes the value 0 given that n takes the value 2. We can make use of the conditional definition, right? So that is nothing but the probability of happening these two events where random variable k takes the value 0 and at the same time n takes the value 2 divided by the conditioning event. What's the conditioning event, or what's the marginal probability? The conditioning event is this PMF where random variable n takes the value 2. What is this event? K is equals to 0 and n is equals to 2. So this probability is 1 divided by 16 and divided by, what's this probability? So this probability is the conditioning probability where random variable n takes the value 2. So this is nothing but 2 plus 1 plus 2, that is 4 divided by 16. So that will be 1 divided by 4. We can draw it here. So we are saying that random variable k takes the value 0 given n takes the value 2 with the probability 1 divided by 4. Similarly, we can find for other cases where k takes the value 1, k takes the value 2, k takes the value 3 given the condition that n takes the value 2. If you do that, where random variable takes the value k is equals to 1 given the condition random variable n takes the value 2, it will have the probability 1 divided by 2. So you can directly, how you can answer these probabilities directly? So you are now in the conditional universe where given condition that random variable n takes the value 2. So this is your conditional universe. What's the total probability of this? That is 4 divided by 16. So you just need to add all these probabilities. That will be 4 divided by 16. What's the favorable? 1 divided by 8. So total would be 1 divided by 8 into 16 divided by 4. So that would be 1 divided by 2. Similarly, you can find the conditional probability when random variable k takes the value 2 given n takes the value 2. So that will be 1 divided by 4. You can directly look at this. Again, the total conditioning probability is 4 divided by 16. And the favorable one is this one, 1 divided by 16. So total you will get 1 divided by 4. For this case, you will have the 0 probabilities. You got the idea? If you have to write this in terms of the mathematics, how you can write? So we are talking about the conditional probability of this event k given n is equals to 2. It has the probability 1 divided by 4 when k is equals to 0. It has the probability 1 divided by 2 when k is equals to 1. It has the probability 1 divided by 4 when k is equals to 2. Otherwise, all for other cases, it has the 0 probabilities. Can you answer this question? Now the role has been reversed. You have given the condition that k is taking the value 2 and you have to find the conditional PMF of this random variable n. you can answer it verbally. So I will leave it up to you that you go through this problem number D and try to find that how I have found this one. It is very easy, right? I am just explaining, that is why it is taking much time. Otherwise I can answer it verbally. So these cases will have the 0 probability where random variable n takes the value 0 given k takes the value 2. It will have the probability 0 when n takes the value 1 given k takes the value 2. It will have the probability that is 1 divided by 16 out of total probability that is 5 divided by 32. So that will be 1 divided by 16 into 32 divided by 5. So that will be 2 divided by 5. So this probability will be 2 divided by 5, and the total probability has to be 1. The total conditional probability has to be 1. So it will be 1 minus 2 divided by 5, that is 3 divided by 5, or otherwise you can use the make of the conditional definition. So this is, we have already found. So this is the PMF of this conditional where random variable n takes the value given k takes the value 2. We will do little tougher problem in problem number 2. Let's look at this problem number 2. Let's go through this question number 2. We have given this joint PMF, and basically we will have to find the conditional expectation, conditional variances. We will be defining some another random variable. So let's first of all go through step by step. Let's first of all understand what is given. We have some experiment, and for that experiment we have defined two random variable x and y, and this random variable x can takes the value little x 0 1 2 3 4, and random variable y can take the value little y 0 1 2 3, and these are the probabilities of happening of these two events simultaneously. If I have to take an example, what's the probability that random variable takes the random variable x takes the value little x, that is 0, and at the same time random variable y takes the value 1, it has the probability 1 divided by 8. So this is the joint PMF that we have given in, right, and these are the probabilities. Joint PMF are also the kind of ordinary probabilities, so they has to be also legitimate. If you add all these possible probabilities, then it will add up to also 1. And for the pair where you have not given any probability, that means those are impossible event and those have the probabilities 0. Let's look at the very first question. We have to find what value of x maximizes the conditional expectation, right? We have already gone through the conditional expectation. If you are not comfortable with these terms, I would recommend to go and watch my previous lectures. Anyhow, let's proceed further. So we have to find that for what value of x we will have the maximum, for which value of x we will have the maximum expectation, right? So let's first of all look at this expression, that is the expectation of this random variable y given x takes the value little x. This is the conditional expectation, and that will be equal to, so here we have to find the expectation of this random variable y, but it is not the normal case. I mean to say, it is the conditional case. You have to find the expectation of this random variable y under this condition where random variable x takes certain value. So what are the values that x can take? So x can take 0 1 2 3 4, right? So depending upon what value it will take, we will have the different expectation of this random variable y, when random variable x takes the value, let's say 0, right, we will have the expectation or the conditional expectation of this random variable y given x has taken the value 0. This is the one expectation we will get. Again, for x takes the value 1, what will be the conditional expectation? X takes the value 2, what will be the conditional expectation? So we will have to find all these conditional expectation depending upon the value that x is taking, and at the end we will have to see which expectation is maximum for which value of x, and that will be the answer to your first part. Let's do that. Let's say this random variable x takes the value, for the case we are talking, let's say this random variable x takes the value 0. So we will be talking about this conditional expectation. Given that random variable x takes the value 0, we want to find the expectation of this random variable y. So what condition we are living in right now? X takes the value 0. So we are right now in this conditional universe. How do you find the expectation? Recall that, right? So random variable y can take the value 0, 1, 2, 3. These are have the 0 probability, so I am not going to consider. Random variable y can take the value 1 with the probability. Now here is the catch. This probability is when you have the complete universe. Since we are talking about the conditional universe, that means you will have to revise this probability according to the condition, right? So it will be 1 into y takes the value 1 with the probability what? Here we will be talking about the conditional probability. So we are living in this universe, so total probability of in this universe is 2 divided by 8, and the favorable one is 1 divided by 8. So total the probability that random variable takes the value y takes the value 1 given x is 0 will have the probability 1 divided by 2 plus this will be 0. Now random variable y takes the value 3 times the conditional probability. What will be the conditional probability? It will be again 1 divided by 2, right? So this conditional expectation will be 4 divided by 2, that is 1 divided by 4 divided by 2, that is 2. Let's take another case where random variable x takes the value 1. All these probabilities are 0, so there is no point of talking about this one. Takes the value x is equals to 2. So in this case we will again find the conditional expectation of this random variable y given that random variable x takes the value 2. So that will be again equal to random variable y given this condition. So we are living in this universe. Random variable y takes the value 1 with what probability? So this will be now the conditional probability. You will have to revise this probability according to the condition, right? So this will be half. So random variable takes the value 1 divided by 1 by 2 plus again this random variable takes the value 2, and this will be 2 into 1 divided by 2. So you are getting this point, right? These are the conditional probability according to whatever the condition we have given, and you know how to find this conditional probability. So that will be 3 divided by 2, right? Again, now let's talk about this random variable x takes the value 4, right? Because there is no point of talking about random variable x takes the value of 3, it will be 0. So in this case, expectation of this random variable y given that random variable x takes the value 4, that would be, so we are now in this universe, y can take the value 0, 1, 2, 3. So 0 times the conditional probability of this. What will be the conditional probability of this? So total probability is 4 divided by 8. The favorable is 1 divided by 8, so we will have 1 divided by 4, and for each we will have 1 divided by 4. Random variable y can take the value 1 into the conditional probability. Random variable y can take the value 2 into the conditional probability. Random variable y can take the value 3 with the conditional probability, and it will be 2 plus 1, that is 3, plus 3, 6 divided by 4, that is 3 divided by 2. We have found all the for all the cases, so we can now summarize it like this. So expectation or the conditional expectation of this random variable y, given the condition that random variable x takes the value little x, that will be equal to 2 when if x is equals to 0, that will be equal to 3 divided by 2 if x is equals to 2, and equal to 3 divided by 2 if x is equals to 4, and it will be undefined. It will be not 0, but it will be undefined. Otherwise, I think I was mentioning for these cases 0, that was not correct. For these cases it will be undefined. Why it will be undefined? So what's the total probability for this universe? 0, right? So you cannot divide by 0. So in that case the probability, the conditional probability has to be defined, so this has to be greater than 0, right? So for these cases it will be undefined, because probability itself will be not defined, the conditional probability. Alright, you have the good idea about this part A. Now let's jump to the part B. In this case we have to see the conditional variance. Again, for each value of y, we will have the variance of this random variable x, and we will have to see that which variance is maximum for what value of y, and that will be our answer to the part B. Let's try to find this. So we have to find the conditional variances in case of this part 2. So let's look at for the case. So basically we are talking about the variance of this random variable x given y takes the certain value, that is little y. So we will have the variances of x based on whatever the value y will take. So maybe y can take the value. What are the values that y can take? Let's look at the case where y takes the value 0. So we are finding the variance or the conditional variance of this random variable x where y takes the value 0. If you recall what is the variance, so we have the formula for the variance, right? Let me directly write in terms of the conditional variance. So that will be equal to the expectation of the random variable x square given y takes the value 0 minus the expectation of random variable x given y takes the value 0 square of that, right? So this one, right? So now we are talking about these expectation given under some condition, that is all, right? So here under this condition that random variable y takes the value 0, so now we are this conditional universe, right? So in this conditional universe x can take the value 4, right? and this has to be the revised probability or the conditional probability. What will be that probability? So we have the total probability 1 divided by 8 and this favorable is 1 divided by 8. So this revised probability or the conditional probability where random variable x takes the value 4 given y takes the value 0 is 1, right? So here the x square will be 16 into the probability, the corresponding probability is 1. So this is the value of this one, right? I hope you are very much clear and with me. Minus what will be this value? So now we are finding the expectation of x, not the x square. So 4 under the condition y is equals to 0, it has the probability that random variable x takes the value 4 given y has given 0, it has the probability 1. Just now we have found iska square, so that will be 0, right? And it has to be 0, right? Variance, we have given some certain event and we are trying to find the variance of that will be anyhow the 0 certain event in terms of the conditional, right? Okay, now let's move further for another case. Let's talk about when random variable y takes the value 1. We want to find the variance of this random variable x given y takes the value 1. So again that will be equal to the expectation of this x square given this condition that y takes the value 1 minus expectation of this random variable conditional expectation of this random variable x y takes the value 1 ka square, right? So here with we are now deciding with this universe, here x can take the value 1 or x square can take the value 1, 4, 16. What will be the revised probability? So 1 divided by 8 divided by 3 divided by 8, so that will be 1 divided by 3. So each probability or each conditional probability will be 1 divided by 3. We can now find the conditional variance of this random variable x given y is equals to 1. So first of all, this what will be this expectation of x square given y is equals to 1. So we are now in this universe, right? So x can take the value 0, 2 and 4. Then x square will take the value 0 square, that is 0 with the probability 1 divided by 3. So this will be the revised probability or the conditional probability according to the whatever the condition we have given, plus x will take the value 2 with the probability 1 divided by 3, or x square will take the value that is 4 with the probability 1 divided by 3. Similarly, x square or x takes the value 4 or x square takes the value 16 with the probability 1 divided by 3 minus this part. So this part will be simply we can write like this, that will be 0 plus 2 plus 4 ka square. So overall we will be getting 20 divided by 3 minus 36 divided by 9. So that will be equal to 9. 60 minus 36, that will be 24. And this will be 8 divided by 3. Similarly, we can find the conditional expectation when random variable y takes the value. What are the other value that random variable y can take? Y can take the 0, 1, 2 and 3. So variance of this random variable x when y takes the value 2, that will be equal to the expectation of this random variable x square given y takes the value 2 minus expectation of this random variable x given y takes the value 2 chi square. So now we are residing in which universe? This universe, right? And the revised conditional probability of these will be half, right? You can find. And random variable x is taking the value 2 and 4. So random variable x square will be taking the value, so with the probability half, so 2 that means 4, 4 that means 16, because we are talking about the x square, minus it will be again half, 2 plus 4 is square. I hope you are able to follow me. So that will be 20 divided by 2 minus 6. So that will be 36 divided by 4. So 10 minus 9, that is 1, right? We can find for one more case, that is when y takes the value 3. So in that case, what will be the conditional expectation? Sorry, conditional variance. So when y is equals to 4, then the variance of this random variable x given y takes the value 4, that will be equal to, so we are residing in this universe, right? The revised probability or the conditional probability of these two will be half. Random variable x takes the value 0. Random variable x takes the value 4. So random variable x square will take the value with the probability half. 0 square, that is 0, plus 4 square, that is 16, minus half 0 plus 4 chi square. And if you do that, how much what you will get is 8 minus 4, that is 4, right? I hope I am not doing any mistake. So this will be 8, and 16 divided by 2 divided by 4 will be 4. So 8 minus 4 is 4. We have got the variances or the conditional variances for all the cases. So when y takes the value 0, we have the variance 0. When y takes the value 1, we have the variance 8 divided by 3. When y takes the value 2, we have the conditional variance 1. When y takes the value 4, we have the variance, conditional variance 4. We can write like this. So the conditional variance when random variable conditional variance of this random variable x given y is equals to little y, that is equal to 0 when y is 0, is equals to 8 divided by 3 when y is 1, is equals to 4, sorry, is equals to 1 when y is equals to 2, and no, here it will be 3, right? Random variable y takes the value 3 because random variable cannot take the value 4, right? So let me erase this one so that we are good. Takes the value 3. When it takes the variance is 2 when y is 3 and it is undefined otherwise. Sorry, it is 4 here, right? So answer to your question of this part B, which value of y maximizes the variance, the conditional variance. So when y is equals to 3, the variance is the highest or the maximum, that is 4. So this is the answer to your part B. I am going slow so that everyone should be able to follow me. right? Now let's come to this part C. We have this r is equals to min of these two random variable. So basically in this part we have been found, or we have defined one more random variable, and that random variable is y, and this random variable, so this random variable is r, and this is nothing but the minimum of whatever the value we could have for x and y. So for example, r, let's say we are talking about this case, so r will, so here x is 2 and y is 1, so minimum of this is 1, right? So r will take the value 1, right? So this is the new random variable that we have defined, right? So we are just considering one more random variable, and that is random variable is r. So for each possible pair we can have the value of r, so we can directly write here. So let's start from the value from this, right? So what will be the r here? So here r will be x is 4, y is 0, so r will be 0, right? R will take the value 0. So how we have defined the random variable, it depends on that what value it will take. And again with the same probability, that is 1 divided by 8, or let's first of all go through all the possible pair. So we will have to see that what are the possible values that r can take, right? So here if you see, the minimum of 4 and 1 is 1, so r can take the value 1. Here the minimum of will be 2, here the minimum will be 3, right? Here the minimum will be 1, and here the minimum of x and y, so both are 2, so it will be 2. Here r will take the value 0, and here r will take the value 0, right? So r can take the value, what are the values that r can take? So let's say this r can take the value little r, and it can take the values. So now I am drawing the PMF of this random variable r. So r can take the values, that is 0, 1 and 2 and 3, right? 0 with the probability 1 divided by 8 plus 1 divided by 8 plus 1 divided by 8, right? So that will be 3 divided by 8, so it can take the, with the probability 3 divided by 8. R can take the value 1 with the probability 2 divided by 8. R can take the value 2 with the same probability, that is 2 divided by 8. R can take the value 3 with the probability 1 divided by 8. Right? So this again has to be a legitimate probability. So 3 plus 2 5, 5 plus 2 7 plus 1 8, 8 divided by 8 is 1. Right? So this is the PMF of this new random variable, that is r. Alright. Now let's move to part D. So we have given this event A, and how we have defined this event A, that x square is greater than y. So this, we have defined this as a event A, and we have to find the expectation of this random variable x into y, and then we have to find the conditional expectation of this random variable x times y given this event A, right? So first let's find out this unconditional expectation, that is x times y. Let's first of all find this unconditional expectation. So this, here we have given the product of two random variable. We can have right? So let's define another random variable, that w, that is the product of these two random variable x and y. So what are the values that w can take? We can simply go through all the possible pair and their product. So here the product will be 0, so w will take the value 0, and here the product will be 12, so w will take the value 12. Here the product will be 4, so w will take the value 4. Here the product will be 8, so w will take the value 8. Here the product is 0, and here the product is 2, and here the product is 4. Here the product will be 0, right? So random variable w can take the value 0 with the probability 1 divided by 8 plus 1, 3 divided by 8. And when a little w is equals to 0, so this is random variable w, capital W, and this is little w, that whatever the value it is taking. Now random variable w can take the value 2 with the probability 1 divided by 8, and random variable w can take the value 4 with the probability 2 divided by 8, and random variable w can take the value 8 with the probability 1 divided by 8, and random variable w can take the value 12 with the probability 1 divided by 8, right? So I hope we have got the every point. So 3 plus 1, 4 plus 2, 6, 7, 8. So we are correct. Now we have to find the expectation of this random variable w, or we have to find the expectation of this random variable xy. We can use the expected value rule to find the probability of this function, that is x times y. So it can take the value 0 with the probability 3 divided by 8 plus 2 times 1 divided by 8 plus 4 times 2 divided by 8 plus 8 times 1 divided by 8 plus 12 times 1 divided by 8. How much it would be? So 12 plus 8 is 20. 20 plus 8, 28 plus 2, that is 30. So it will be 30 divided by 8, or if you would like to simplify this, then this will be 15 divided by 4. Now let's try to find this conditional expectation. So conditional expectation of this random variable w, given that what's the condition a, right? Or in other words, you can write like this. So conditional expectation of this random variable or this function, given that x square is greater than equals to y. Let's first find out our conditional universe, right? So x square should be greater than equals to y. So here what we can do, we can go through and so x square, here all the values of x will be 0, right? So x square will be 0, comma y will be so 1. Here x square will be 0, y will be 3. Here x square will be 4, y will be 1. X square will be 4, yes 4, and y will be 4. X square will be 16, y will be 0. X square will be 16, y will be 1. X square will be 16, y will be 2, and x square will be 16, y will be 3. What's our conditional universe? Conditional universe are where this condition is getting satisfied. Definitely these are not getting satisfied because 0 is not greater than equals to 1 or 3, right? So this is our conditional universe. If you look at this, 4 is greater than equals to 4. Yes, 4 is greater than 1. 16 is greater than 0. So this is our conditional universe. And in this conditional universe, first of all, what we will have to do, we will have to revise our belief or revise the probabilities, or we will have to find the conditional probabilities. How we can do that? We can do that simple. So what's the total probability? Total probability is 1 divided by 8 plus 1 divided by 8 plus 1 divided by 8 plus 1. So how many are these? 1, 2, 3, 4, 5, 6. So total is 6 divided by 8. And we will have to go through each one, right? And in conditional also it will be equally probable. So let's, if want to find for this case, so it will be 1 divided by 8. So overall it will be 1 divided by 6. So each will have the revised probability 1 divided by 6. I hope you are clear that how I am saying that. Right, so what will be the conditional expectation now? So random variable, so these are the product, right? So we have already written the product values or the values of W, right? So in conditional universe, it can take the value 2 with the probability 1 divided by 6, or let me write down like this because all are equally probable. So let me write down 1 divided by 16 outside, and the sum of these product in the conditional universe, right? So that will be equal to 8 plus 12 is 20 plus 4 24 plus 4 is 28 plus 2 30 divided by 6 will be 5. Right? So you see, if you have good understanding, then you will not have much difficulties finding these expectation values. We will see more problem, right? And also I will be putting problems, a lot of problems on our practice session. So how you can access that? You can just go to the mindspaneducation.com and you will see the probability section there. So if you want to have a practice problem, more practice problem, so first of all you need to enroll for that course, right? And the enrollment fee is, you can say, it is very minimal cost. So you will not have to think price wise, right? So once you will enroll, you will see the quiz section, and once you click on that, then you can go through the chapter wise quizzes for the probability. So we have already made the separate video for that, how you can access, right? So similarly, how I have done for the linear algebra, same thing I have done for the probability also. So you can just go and enroll and start practicing the question, right? And even our calculus lectures are already going on, so you can enroll for that one also. All right, that is all. We will have few more things in the discrete part, discrete probability. I think maybe 1 to 2 lectures upcoming, and then we will be jumping to the continuous probability, right? So no concept that will be left out. The every term that has been mentioned in your GATE DS syllabus will be taught thoroughly, and you will have the good understanding of the subject, right? So that is here what we are making sure of that. That is all in this video. Thank you.